Hi, today I'm going to be proving the property that the biggest power of a prime p that can evenly divide x factorial is equal to x over p to the power 1 floored plus x over p to the power 2 floored plus x over p to the power 3 floored plus x over p to the power 4 floored. Let's say x is equal to 9 and p is equal to 2. The biggest power of 2 that can evenly divide 9 factorial is 9 over 2 to the power 1 floored plus 9 over 2 to the power 2 floored plus 9 over 2 to the power 3 floored, which is equal to 7. We're not considering 9 over 2 to the power 4 floored because that's less than 1. And if you floor something less than 1, you get 0. And if you add 0, that doesn't make a difference. Same with this above statement here. If p to the power 5 is greater than x, then we're gonna stop at p to the power 4. If p to the power 5 is less than x, then we could add plus x over p to the power 5 floored here. But since we're just taking these four just for simplicity, this is equal to 7 because 9 over 2 to the power 1 is equal to 4.5. You floor that, you get 4. You add that to 9 over 2 to the power 2 floored, which is 9 over 2 to the power 2 is 2 and 1/4, and you floor that, you get 2. You add that to 9 over 2 to the power 3 floored. 2 to the power 3 is 8, and 9 over 8 is 1 and 1/8. You floor that, you get 1. So you have 4 plus 2 plus 1, which is 7. Today we're going to be proving that property. So let's just say x is equal to 9 and p is equal to 2 again. We're going to represent 9 factorial in the expanded form, kind of expanded form. 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. All the multiples of 2 here represent 2 to the power 1, right? Because all the multiples here have 2 to the power 1 in it. So 9 over 2 to the power 1 floored is going to give us how many 2 to the power 1s there are, or how many 2's there are in this 9 factorial, which is equal to 4. So we floor it because, if it was 10, we couldn't use 10 because, it's greater than 9, and we don't have that over here. We don't have that option. And any time, if we have a multiple of 2 greater than 9, we're not going to be considering that because 9 is the limit. So we floor to make sure it's not going to go above 9. Let's consider the multiples of 4. That's a bit different because actually they contain 2 2's. That's 2 times 2. One 2 was taken out because we did the multiples of 2 here, but the other 2 still remains. We still have to use that. So the multiples of 4, all the multiples of 4 still have a remaining 2. So we do 9 over 2 to the power 2 floored is equal to 2 for the same reason as the last one. Now, for a third 2, we took away all these 2's, but we still have remaining this 2. If this number was 18 factorial or something, we would also consider 16 because 16 also contains another 2. But since it's only 9, we can do 9 over 2 to the power 3 floored, which is equal to 1, and we won't have to worry about any other multiples of 8. So now we've taken all the powers of 2. We have to add them because that's how we're going to find the total. So we add it and we get 7. And that's what we got in the earlier slide. So that proves the property.